Good morning or afternoon or evening. Just love working with global communities. Today, I have Lee and Kevin joining me today to talk about the brand new DynamoDB Data Modeling MCP server. Very excited about it. We're not just going to talk about it, we're actually going to see it work today. I'm not going to steal a lot of thunder. I'm just here to say hello, everybody. Good morning, good evening, good afternoon, and hand it over to you guys.
Yeah, thanks, Alan.
Lee and Kevin, good to see you. I'm going to be behind the scenes. I will say goodbye and good luck.
Perfect. Yeah.
Thanks.
Thanks for having us, Alan. Good morning, good afternoon, everyone. My name is Leeroy Hannigan. I am a specialist solutions architect with DynamoDB, and with me here is Kevin. I'll let Kevin introduce himself.
Hi, I'm Kevin Willis, and I am a product manager on the DynamoDB team.
Excellent. Cool. So to start to get into DynamoDB data modeling, I suppose the first thing we need to realize is why do some people consider it a hurdle? And we'll talk a little bit about the mindset shift if you're coming from a relational background. So if the way Kevin and I put it is that when you are data modeling for a relational database, it can be, I wouldn't call it easy, but you have a set of rules to follow. 3 rules to put it into third normal form, and you get a normalized data model. And you put that data model into your database, and the query planner figures everything else for you, does all of your joins and things like that. So you have a query planner there, something that doesn't really exist in NoSQL databases, and most definitely doesn't exist in DynamoDB. So when coming to data model for DynamoDB, we have to take a different approach. And we often joke that it's more of an art than a set of instructions. If you give a problem, a data modeling problem to, let's say, the specialists that work on my team, then probably each one of us would come out with a slightly different data model. And that's that kind of the artistic nature of it. Kevin, would you agree?
Yes, I think so. I think it like you said, it's an art. And it also depends on like how much information you gather, right? You might ask different questions, I suppose, each of you as well. And so you might uncover different stones. And so, yeah, I think it's certainly an art.
Yeah. So the biggest hurdle that we see with our customers who are trying to adopt DynamoDB, let's imagine for years they've been running relational databases, whichever flavor it may be. And for many different reasons, they choose to adopt DynamoDB. It could be because they've exceeded their expectation on scale. They're looking for a more managed service that's a serverless service, and why we're here today. But they have to model their relational data in what is used for DynamoDB. So it's in denormalized fashion rather than normalized fashion, where it's okay to store duplicates. It's not against the law to store duplicates in a non-relational database. So an awful lot of my time as a specialist solutions architect for DynamoDB is spent helping customers adopt their data model or design their data models. You know, a lot of the time they'll design their data model themselves or with the help of others, and they get to a point where it's not doing exactly what they need to do. And that's where I step in. It's like, well, if you make this little change here and this little change here, now you'll see better latencies, you'll see maybe less cost, because again, your data model is also very important when it comes to cost in DynamoDB.
Lee, could I ask you what percentage of time do you think you would say that a customer goes through modeling data versus all the other tasks to move from a relational database?
Yeah, that's a good question, Kevin. I mean, let's think of somebody who's been buried in relational databases for years and they haven't really come to the NoSQL world. They're going to have to go through pages and pages of documentation just to understand the different things. For example, partition keys, sort keys, how indexes behave differently in DynamoDB compared to your query planner figuring it out in a relational database. So there's an awful amount of time spent just scanning documentation to learn the fundamentals. And that documentation is not for your specific use case. That documentation is kind of geared towards everybody, just to give them a kind of step up to understand how DynamoDB works and the core components of it. So you first have to cross that hurdle, and that can take any amount of time from, you know, hours to days, maybe even weeks, depending on how much time you allocate to it. Then what I see customers typically do is they start watching maybe videos from previous reInvent sessions or some of Alex DeBree's videos. They'll get Alex DeBree's book perhaps, and they'll
Shout out
yeah,
to Alex.
so they'll figure these things out as they go along, and it is very time consuming. And what we're trying to do with the DynamoDB MCP server is to save them all of that time. All of that time of reading documentation, of learning the fundamentals, and we're trying to kind of package it all in a single MCP server where, you know, it's geared toward your specific use case. You're asking in plain English about your specific use case, your application's requirements, and we're going to tell you what core concepts or what fundamental things that you need as part of your data model that will succeed on DynamoDB.
Yeah, I think that's interesting because, you know, if I say it back, you could spend a lot of time reading the documentation, and you might learn about 20 various features, but at the end of the day, you only needed 10 of them to express your query patterns. And so with the MCP server, we can kind of narrow down the scope of what you need to learn to get started.
Yeah, totally agree.
Awesome.
So today we're going to show you an example of, first of all, installing the MCP server. I'm going to use the QCLI, or maybe I'll take a step back. Why MCP, I suppose, is an important thing here. We've iterated on this data modeling tool for about a year. We came up with an internal version that was web facing. It was back on a website, and you visit this website, and we used R models for the agentic AI part of it. And that worked quite well, actually. But then we thought, okay, so what about this corporation who are locked into a certain vendor? Maybe they're not allowed to use Bedrock. Maybe they're not allowed to use Claude, for example, and things like that. So we've limited the access to the tool to just the people who are allowed to visit, third-party websites, which would be that case. And MCP suddenly became this huge thing, and typically it's used for making external API calls, or hitting a database or RAG or something and fetching data that way. But we sort of carved this little niche into MCP where we just provided context. Now that context is made up of all of the solutions architects for DynamoDB's knowledge. We've iterated and tested on it using an evaluation tool that we built in-house, just to make sure we keep getting better context or better prompts as we move forward. So quite a lot of work has gone into it. And the beauty of it is that you can now use this in whatever Copilot you use. So if you're using Amazon Q or Kiro, or maybe you're using Claude Code, Windsurfer, Cursor, you now have the ability to get domain expertise within your Copilot of choice. And I think that's the main thing with MCP for us. Would you agree with that, Kevin?
Yeah, I think so. I think, we know that a lot of developers are using AI copilots, and developers spend a lot of their time in an IDE, right? And so how do we bring the experience right into that chat interface while you're chatting about fixing a bug or designing a new feature? You could talk about the DynamoDB data model right there. And I think the other thing that's intriguing about MCP is this ability to use multiple MCP servers in one seamless chat. So, today we'll demo this ability to design a data model, but you could envision having, let's say, the AWS API MCP server installed and ask your AI agent to deploy that data model as well.
Yeah, totally. So we have this MCP that's available to basically all of your coding agents. And like you said, it's adaptable, that you can plug in other MCPs that can kind of, you create a data model here, and then maybe you ask the AWS MCP server, can you create the tables based on this schema? Can you test it? Can you add some items? And you can iterate through then maybe building out your code and testing the APIs against the AWS web service. So let's see how we install the MCP server. It's quite simple. We just go to the AWS Labs GitHub repo, and we install it using just this simple bit of MCP JSON. So on the GitHub page itself, it will have this sample JSON output, and we just save that in a file called MCP JSON, which sits under this .amazon queue. Now, .amazon queue can live in your project, or globally, it can live in the .aws file, which is where you configure the CLI, for example. So it's just MCP servers. You'll have a list of whatever MCP servers you have installed. For me, I just have the DynamoDB MCP server. One of the prerequisites is that you have UVX installed, or UV. The argument is that we're using the AWS Labs DynamoDB MCP server, and we're calling the latest version. If you stay on the latest, it means that every time we update the context, you will be able to avail of that straight away. And that's another kind of fundamental benefit of the MCP server, is that, let's say, for example, DynamoDB adds a new feature. All we have to do is update that context, and now all of a sudden your data modeler tool here can avail of that new feature. If you were relying on the LLM itself, you would have to wait maybe several months for them to rebuild and pull in new documentation and things like that. So it can be quite stale. When you use this sort of thing, it means that we can update it as soon as that feature is launched, so you can avail of any kind of new features that come to DynamoDB. We have some environment variables. These are likely going to be removed, but in the past we had the ability to do the CRUD operations in DynamoDB through this MCP server. They get pushed up to the kind of Amazon or AWS wide MCP server that has CRUD APIs for almost all services. So we don't really need to keep credentials or region or to make it read-only. So these will likely be removed in a future iteration. Simple as that. Yeah, sorry, go ahead.
Oh, sorry. Could I go? I want to add to that. I think that's actually a better user experience too, because that all-up MCP server, you have every AWS API, as we mentioned earlier. If you had the DynamoDB MCP server and that one installed, you could describe in natural language the data model that you need, and then have your AI agent use the other MCP server to actually deploy that. But oftentimes customers need to use multiple AWS services, right? So you could be talking to those other APIs as well. So I think it's a great user experience, and that's one of the reasons we want to move that way.
I totally agree with that. Yeah. For example, if you're setting up DynamoDB streams with Lambda and things like that, so now you've got the ability to create Lambda functions and iteratively test with that. So once we've installed that, we save. And for this demo, I'm going to be using QCLA. Now you can use the MCP server, like we said, in any of the kind of coding agents that you use. You can use the Q desktop, you can use Claude Code desktop, OneSurfer, Hero, whatever it is that you want to use. But for this demonstration, I'm just going to use Amazon Q on the CLI.
And I'll add there is we're going to be sharing the link to the blog and to the GitHub repo. These installation instructions are there. If you use other IDEs, likely there will be a one-click option for you to install it. If you prefer the chat interfaces, you can do that as well.
Yeah, totally. So let's have a look at what tools are available now. If we do /tools, and we can see that this is our MCP server, and we have the DynamoDB data modeling tool. So I have this kind of pre-created example application. It's for a ticketing system for concerts with artists and things like that. But we'll have a look through the access patterns now. This is where data modeling differs with DynamoDB compared to relational database. We always work backwards from our access patterns. It's the fundamental kind of core concept of data modeling for DynamoDB. So we're going to be getting all upcoming concerts by city, get concerts by artist ID, get concert details by a concert ID, list artists followed by a user, list followers of an artist. We want fan out notifications when a concert is announced. So if an artist launches a concert in New York, all of the followers should be notified of that concert. Record ticket purchases for a user and concert. List of users' upcoming tickets. Then we have this kind of curveball where we want to search concerts by keyword. And we'll get to that when it comes up. And get top concerts by popularity. So let me just copy this And I'll take the header too, and I'll ask, can you help me design a data model for DynamoDB with these access patterns? Let me just pull this up a little bit higher. So here you can see that it's called the DynamoDB tool within our MCP, and we're going to hit yes to allow it to call that tool.
Lee,
You can
what
also,
I think another interesting point about MCP, we were talking about why MCP. One of the things we looked at is like, what about just a prompt? Like we could put this context on the web, and you could have it in your project, and you might have a tool that allows you to do like \prompt. But MCP gets you this experience right here, where in the natural language, you describe what you want to do. Your AI agent knows the tools it has available through the MCP server, and so it then makes the decision what to do. And so this was seamless. You didn't have to specify it.
yeah, that's exactly it. So the first thing it's going to do is going to create this document called requirements.md. So I'm going to let it go ahead and create that, and I'll give you a brief overview of what that looks like. So it knows that it's a concert ticketing system. It's managed to kind of pull up the key entities for that application, the business context and the scales to be determined. So it definitely needs to incorporate what kind of scale that you're going for, because that can, really emphasize or impact the decisions you make around data modeling. So number one is the access patterns, and number two is your kind of expected scale. Then it will log out all of our access patterns. It's saying here that, here's the get all upcoming concerts by city. The RPS, or the request per second, is to be decided. It's a read type. The attributes that it thinks you need. Now you can always tell it, hey, I actually need an additional attribute for this read. It's also made this.
A great point there to add is like, whenever you're coding, let's say with your AI agent, it generates a script, and you might be able to look at the diff, right? And then you decide to accept the changes. This is kind of giving you that experience where it's generating this requirements document based on what you said to it. Now you can review it, and you're in preview mode. You actually could double click in here and just change this as well. Like if it gets something wrong, just like a human could, you could click in here, and it's a little bit hard to see because we're zoomed in, but you might add another attribute or two that you think that you're going to need.
Yeah, that's exactly it. You can edit it in real time. So it goes through them all, and it's saying here that it needs a GSI city with date as the sort key, which, if you know about DynamoDB data modeling, that is what you would do here. So it goes through all of this. It pulls up the relationship. So it's saying that there's a one-to-many between users and tickets. There's a many-to-many between users and followers, artists and concerts, and so on. So it's pulling up the relationships, which again, some people think NoSQL databases don't have relationships, but yeah, they most definitely do, and they play a huge role in when you're trying to design a data model. Aggregate analysis is basically how we create the item collections in DynamoDB. So how we aggregate the data together. Should it be stored together, or should it live in a different table? So those are still to be defined, because it needs the request per second or scale. Then it's calling out some sort of scratchpad where it's thinking about design considerations. So popular artists and concerts could create hot partitions. GSI projections needed to balance cost versus performance. So you have all of these things that it pulls up that it's thinking about already before you even go further. And it's when we get further, it's when it can actually come to that. So before it makes the data model for you, it has to satisfy all of these. So the domain and scale is documented. All the entities and relationships are mapped. The aggregate boundaries identified based on the access pattern. So again, that's your item collections, identifying relationships, and so on. So for it to actually create the data model, it must satisfy this requirements document. So let's see what it says. Scale estimation, what's your expected scale? This helps estimate the RPS for each pattern. missing write patterns. I'm just going to skip them for this session, but it's telling you that you've got read access patterns, but I don't notice that you have any write patterns for that. Do you want to add them? Which typically you would, but for the sake of this demo, we'll just skip. And then notification requirements for the fan out notifications. Do you need real-time push notifications, or is eventually consistent push notifications acceptable? So I'll go back to my thing where I have the scale laid out. Let me just pull this up in preview. So I have total registered users 5 million, monthly active users 1 million. I wish this was my application. I wouldn't be sitting on this call with you today. I would be in the Bahamas, maybe. So yeah, let's just give it this what we have here. We'll just paste it in. So number 1 is the scale. Oh, 1 is the scale. 2 was asking about the access patterns or the additional access patterns. Let's work with what we have for now. And 3, I'm going to
go ahead.
Sorry, go ahead, Kevin.
I was going to say, one of the things that's interesting about this is that when you previewed the requirements file and these types of questions it's asking you, it's all baked into the context that we've designed. And this was, an iterative process where we go through this hundreds and hundreds of times to see where an agent's going to trip up or where we want it to do something in particular that's very specific to our process for modeling data with DynamoDB. These questions about, I see these read patterns, but I don't see writes. Like those are things that we tell the agent, like, hey, we want you to do this. And so it's through this iterative process. And even the checklist, for anybody that's watching who is trying to design a prompt for an AI agent, those checklists, they serve as a gate for the agent that these are the tasks it has to complete. And it really does help.
Yeah, some of the many hard learnings we've had from designing prompts for MCPs. Thanks, Kevin. So, okay, let's give it this information, and we'll see what it does. It will actually start to update our requirements file based on the things that I give it. So it's asking me for permission to do so, which I'll say yes. You can also hit T, which is trust the tool, but I like to review what it is actually trying to do, so that if I notice a mistake up front, I'll say, hey, no, that's not exactly what I'm looking for. Do it this way instead. But if you do trust with T, then it will just go ahead and automatically write to that file for you.
Yeah, again, same. I tend to want to see what it's doing. Otherwise, like if you go back to like this vibe coding scenario and it's writing code, like the AI agent is very eager. Like it'll go off and write 5,000 lines of code, and then you're kind of stuck figuring out how to read it all.
Yeah, totally agree. Yeah, stay in control, be the human in the loop. Cool. Okay, so let's see what it's added. So it's broken down the RPS, which it thinks is broken up with the scale that we give it. We can, again, like we said, you can adjust this either directly in the file or by telling the LLM or the MCP server that, hey, the scale for this exact access pattern is actually more or it's actually less. So we'll keep accepting the changes that it's making to this file. Nothing has changed in the interrelationships. Here now it's starting to get the aggregate analysis. So we're looking at 80% of queries need user tickets and concert details, pattern number 8. So user profile by itself is 20% of your queries. Tickets only is 5% of your queries, but both together makes up about 80% of your queries. So that's a natural fit for combining those into a single table, which we'll see. Size constraints, that it's under 2 kilobytes, and the average is 10 tickets per user. So 32 kilobytes, which it's saying is bounded growth. Again, artists and concerts, it's saying that 60% of the queries need the artist and their concerts together, which would make sense. You click on an artist, you want to see where they're playing live. So it's gone through all of those. And then it's going to go the consolidation candidates review. So it's basically just a table layout of what we seen a second ago, that it's saying, hey, this is a good candidate for consolidating into a single table. Likewise for this. User and his followers, okay, they don't need to be contained within these two tables. That's fine as a standalone separate table, again, with artist and their followers. Hot partition analysis. So again, this is something that's fundamental when you're trying to design data models at scale with DynamoDB. So it's saying 2,000 writes per second during flash sales can be a hot partition risk. So popular concepts would exceed 100 writes per partition. And it's saying here that write sharding on concert ID for ticket purchases would be a good solution to handle that write sharding, or to handle that hot partition scenario. So to break it down, DynamoDB, every single partition in DynamoDB can handle 1,000 write capacity units per second. If you have one partition key that is trying to achieve more than 1,000 write capacity units per second, then it could become hot. And when a partition becomes hot, it's basically DynamoDB telling you that, hey, you need to slow down, you're going too fast for this partition. And what will happen is you will actually get exceptions in the form of throttling exceptions. If those throttling exceptions are minor, then you get sort of your SDK will automatically retry. But if you're really aggressive and you're constantly pushing above 1,000 write capacity units, then it could lead to some of your writes failing, meaning that the application will have to do something about it, which you want to avoid. Okay, so it's still updating a few things.
And one of the things, here we're kind of instructing the agent behind the scenes to take notes. Like, this may not really be the final data model. It's just from the information it has so far, it's trying to write those things down. And we wrote in there, you see that section where it says subject to change. So this is like its scratch pad. It's just taking down some notes. And we see one of the reasons why we design it like this is that we're trying to get it to perform certain behaviors later on. So we're trying to give it this almost personality through taking notes in a specific way.
Yeah, precisely. So it gives us some output. We sort of went through it already when we went through the requirements file, but it's just giving you kind of a summary of what happens. So there's a critical hot partition risk for pattern number 7, where you have Taylor Swift or someone that's playing a huge concert in maybe New York. It's going to get a lot of ticket purchases per second. And that's what it's trying to avoid. Given our scale of 1 million active users, that's a definite possibility. And then it's asking, hey, should I proceed with the data model? You can, of course, change some things based on the requirements file or based on the output that the MCP has given you, but we're just going to say yes, please create it.
Going back to what you were saying earlier, Lee, about how it kind of short circuits the learning process in a way. If you're looking at DynamoDB for the first time, even if you have NoSQL experience, that doesn't necessarily translate to DynamoDB, right? You may not even know what is the best practice for documenting your access patterns. What are the things like RPS, consistency, and so on that you want to be aware of before you go into design. And then now that we're kind of past this requirement gathering phase and we're starting to get to the design phase, even seeing information about hot partition risk because it's 2,000 writes per second, like that gives you an angle of learning now, to go verify, oh, okay, what is the partition limit? Maybe I didn't know about that.
Yeah, exactly. And it's specific to your use case. Once again, you can go through the data model or the documentation, and you can see things in there about hot partitions and what scale a partition can handle. But trying to put that in your mind with your own application, I know I'm doing 50,000 writes per second, for example, but how do I know if that is going to cause a hotkey? 50,000 is greater than 1,000, so now you're thinking, okay, maybe DynamoDB is not a fit. But in reality, is if that 50,000 was spread evenly, then you have no problem. This tool gets to give you your application specific guidance.
Yeah. The other thing that's interesting here is that in documentation, you kind of have to gives only a few examples. It's hard to go into an example for every type of application, but when you give an AI agent one example and a little bit of context, then it's pretty good at generalizing now across different types of applications.
Yeah. So let's go ahead and create the DynamoDB data model. And again, we'll pull that up in a preview for you so it's easier to see. And get rid of this and drop this. Okay, so it gives us some of the kind of background to the choices that it's making. So the design follows aggregate-oriented principles, which means you're making use of DynamoDB's item collections. An item collection in DynamoDB is all data that's related to a given partition key. For example, you have a user ID that has many different, a profile and ticket sales or whatever associated with it. It creates that one-to-many relationship for you, and that's known as an item collection. So it's giving you some of the kind of background to why it's done these things. Again, it's telling you about the correlation of how your access patterns wants to fetch that data, and that's the reason why it's decided to use them in item collections. It's also telling us here about the write sharding, that, hey, that hot partition problem, we're going to handle it through a kind of an approach known, or a solution known as write sharding. And we'll see that here from an example. Again, just really kind of doubling down into why it's made the decisions for the data model that it has. So seems like some of the file is missing this time, Kevin.
Maybe scroll up and see what it's saying down there. There you go. It's just asking.
It's just asking. Yeah, I was thinking. I've not seen it do that, so I was thinking that this doesn't seem right.
Sometimes it depends on how, like, if the data model is going to be fairly complex or a lot of patterns, it might need to write to that markdown file multiple times, because depending on the AI agent, there's a limit on the number of rows or that it can write to the file at once.
Sure.
So that's where I see that come up.
Yeah, it could have been that I opened it up in preview while it was still writing, and it probably errored out. But yeah.
Yeah, so it's doing its thing. I saw this just this morning. I was tinkering with the data model, and I think I had, here we have I don't know, what do we have? Maybe 10, 12 access patterns or so. I think I was like at 40 or so. So it's pretty comprehensive because I went through all the writes as well. And it had a limit to the number of lines it could write at once. So I did have to go through this process of just letting it, ask me, is that okay? I in this case, since I know what I'm doing, I just trusted it. For this case, like, I just thought, I want to get through this, but
yeah, even though it would have been much easier for me to hit trust with T, I just am in the habit of always keeping an eye on what it's doing.
Yeah.
Cool. So let's take a look at one of the tables that's here. So we're looking at the user tickets table. You'll notice that we're some people will call this single table design. I don't like to call anything single table design because it gives the false impression that perhaps everything should live in one table, and that's often not the case. And it really adds complexity rather than help you with your data model. So here we have the user profile, John Doe's user profile. He is user 123, and then we can see the tickets that they purchased. So we'll see Rock Festival and Jazz Night. Again, with user 456, we have their profile and their ticket. Now, this gives you the ability to either get their profile or update their profile on its own, to get tickets, all the tickets, a single ticket, or update a ticket as well. But you can also do this in a single request where you get the profile and all of their tickets in a single request. And that can be quite useful for populating, your application screen where it's showing your user profile and a list of the tickets that are coming up in the future for you.
And Lee, to your point, I think, as we'll see in this design, we've got multiple tables here, right? And really what it was doing, the aggregate design analysis, right? It's trying to figure out, like, what are the entities you have? How do you access them? How frequently do you access some of them together? And so it's strategically figuring out how to group certain things in one table. But if there's something that's not related, it's not going to be queried together ever, then it's beneficial potentially to have it in a separate table, because then you could back it up independently. You have independent streams for that table and so on.
Yeah. There's many valid use cases for storing things in a standalone table. They might have a different data lifecycle. They might, your backup strategy might be slightly different. Handling things like in your streams, or if you're using event bridge pipes and things like that, get much more easy. You don't have to think about filtering. So yeah, there's many reasons and advantages to using multiple tables. So my rule of thumb is that if the data needs to be read together, then it should live together. Otherwise, separate tables is totally fine. Cool. So that is one of the tables. It's breaking down the kind of why it's done these things. So it's telling you about the sort key is now two different kind of entities. Profile is the user profile, and the ticket is the ticket ID. So for the individual ticket. And that means you can add as many tickets as you want. You're not bounded by this 400 kilobyte limit that DynamoDB has in an item size. So one kind of common mistake that I see is that they'll add maybe a list of tickets to a user into a single item, and that list is unbounded. So you keep on adding new ticket information, which could be a map of, you know, maybe 100 bytes or a couple of 100 bytes. But as that keeps growing and growing over time, your updates to that item gets more expensive. And you also run the risk of maybe exceeding that 400 kilobytes, which means you'll get an exception saying, hey, your item's too large.
Yeah, and I guess if you have somebody that goes to a lot of concerts, that whenever their ticket history loads, it's going to be a little different, right? You can't hardly paginate through that.
Totally. Cool. Okay, so then we're seeing the upcoming tickets GSI. So this is a global secondary index that's built onto that same table. This time it's with a date as the partition key and the user ID and hashtag ticket ID as the sort key. So it enables efficient querying of updating ticket for date pattern number 8. Here's where this is showing you the concerts that are on per day. So let's imagine you're in an application and you want to see what's on tomorrow or what's on, you know, next Thursday or next Saturday or whatever it may be. This would be able to show you all of what's on. Then we have the artist concerts table. So the artist concerts table is the kind of profile for an artist. So you're in your ticket application and you click on an artist and you see their profile. So a little bit about them, who they are, what band they might play with and things like that. And then you see the concerts that they have coming up. So again, that's
one of the things I just realized as we're looking through this, if you kind of pay attention to the names, to the titles we're seeing here, the venues. So I was in ticketing before. I worked in technology at a technology company. So like I know some of these venues, and we didn't tell it that, right? It just used its own creativity, and I think that's where like the AI agents can be powerful in these design scenarios, because generating fake data is not so simple. And so here it's done a pretty good job at using its imagination, filling out what these tables are going to look like. And we're not really using AWS services yet, right? We haven't logged into the console or we haven't done anything like that, but we are seeing some tables of data here that kind of give us a direction of what this might look like.
Yeah, I totally agree. I think it's that sort of happy medium where we're given it strict instructions to do things the DynamoDB way, but it also gets inventive in its own sense where, you know, it's coming up here with some data, which we'll discuss kind of the possibilities that may bring just once we get through this. But for now, we can just finish through this. I think it sort of makes sense that what it's built here, it's got a user artist follows table. So for a given user, which artist they follow. And again, you can do this in a single request where you say user ID is 123, give me all of the artists that they follow. And then you have the inverse of that where you have a global secondary index with the artist ID, this time as partition key, and now your user ID is the sort key. And that was for that notification where an artist announces a concert and it wants to notify all of its followers, hey, I've got a new concert in New York, come and buy tickets. So you can just, you know, do a really quick query on this global secondary index and you can get that. And then finally, we have this ticket purchase table, which I want to discuss a little bit about the right sharding. So we can see here that it's only showing two variants of concert 789 and concert 456. Really what we're trying to do here is, okay, we know the upper limit for a DynamoDB's partition is 1,000 write capacity units per second. Now, let's imagine you envision, for example, 10,000 writes per second to that concert. Then you would break up into 10 random shards. So from 0 to 9, you would be concert789 hashtag 0, concert789 hashtag 1, all the way up to 9. That would give you 10 shards. That would evenly distribute it out across 10 different partitions, each one of them giving you 1,000 write capacity units. Now, what I typically discuss with customers that need write sharding, now this is again on the upper end of data modeling. It's once you start hitting large scale is when you run into this sort of thing, is that I would leave myself a little bit of a buffer room. So I know 10,000 writes can be handled by 10 partitions, so I create 10 random shards, but I want to leave a little bit of a buffer room. Let's imagine that maybe 2 of those partition keys hash to the same shard, or the hash to the same partition within DynamoDB rather. Then both of those are only able to get 500 write capacity units each. So if you create a little bit of buffer, let's say we go for maybe 12 or 15 shards, that gives us a little bit of headroom. And again, we're expecting 10,000, maybe we hit 7,000, maybe we hit 12,000. So you have a bit of headroom from the application standpoint as well.
I guess, Lee, in a data model like this, if I were to give you the same set of access patterns, but let's say it's only 10% of the throughput that we described, that's where the art comes in, right? It's like, well, you probably don't need to introduce this much complexity. Keep it simple. And I think that's that, art. Whereas if we're in the relational world, we're going to kind of always start with following these 3 rules of third normal form and building up our data layer. And then we might run some queries and build out indexes and so on afterwards for performance. But here it really is, it could be dramatically different. The data model could be depending on throughput, I think, right?
Yeah, it's completely dependent on throughput. The access patterns that I provided, the MCP when we started, I specifically choose things that would throw these curveballs at it, just to showcase that, hey, it can overcome your problem that 2,000 writes to a single partition. We can do that with write sharding. So I just finish up then by the search. So we wanted to be able to search concerts by a keyword. And if anybody has worked with DynamoDB, you're familiar that it doesn't do search. Well, it's not built to do search. It's built to do OLTP, or online transactional processing. So high throughput, low latency. Search doesn't really fall into that category. And here it's suggesting that we use OpenSearch. So we want to have a DynamoDB integration with OpenSearch. So with DynamoDB, we have that zero ETL integration with OpenSearch. That means that you can, basically allow AWS manage the replication of your DynamoDB data into an OpenSearch serverless domain or cluster, whatever you have. And there you can do your search. So you only need to project certain attributes into that domain. Maybe, the keywords, that maybe it's the title or the artist or something like that. And that's where you get that kind of, you allow a tool like OpenSearch that's purpose built for search to do your search functionality, where DynamoDB handles your low latency at scale. And finally, then it's telling you that, hey, our hot partition was handled by sharding. It gives us these little green ticks, and we're all good. We sorted it out. And then it's saying that there's some trade-offs and optimization. So it's saying that item collections, user and tickets, and artists and concerts reduce the query operations by 80% and 60% respectively. So we're trading storage for performance. Write sharding, it's telling us again that sharded across 20 partitions in this case to handle any spikes. Denormalization, concert details are duplicated in user tickets to avoid joins. So again, that's where it's okay in DynamoDB to store duplicates. It's very unlike a relational database, and I like the outputs that this tool gives you. It's actually saying, hey, I'm giving you a license to go ahead and store duplicates. And then it finishes off by, again, Kevin mentioned the power of, kind of forcing a checklist on an LLM. It kind of keeps it in line almost, or a gate, like Kevin mentioned. So here it's making sure that it, ticks all the boxes before it actually gives you the data model.
Lee, what are some of the things? It's data modeling is complex, and I don't think we've perfected this tool yet. Like, what are some of the things you've seen where you think we might improve about the data modeling logic?
Yeah, the data modeling logic. So we have the evaluations tool, which you'll actually see on our GitHub as well. And we use that to any change we make to the prompt, we want to make sure that we're always getting better and we're not regressing. So, some things that I would like to do or that I plan to do is, have more context around maybe that zero ETL integration with OpenSearch, or maybe our zero ETL integration with Amazon Redshift and Amazon S3. And instead of telling the user that, hey, you can do this, it's actually saying now, hey, you can do this, and this is specific steps that you need to take. Here are the kind of options that you have to maybe cost optimize or optimize for performance and things. So not just give it really good DynamoDB data modeling, but also the auxiliary services around it. So for, if you're streaming into a Lambda function, what's the best way to build that Lambda function? How do you optimize it for performance and scale? Likewise with Event Bridge, how can we use pipes? How do we apply filters? Things like that. So yeah, for me, to enhance the data modeling, we have to enhance the auxiliary services around DynamoDB, because DynamoDB is really good at what it does, but it relies on these, if you're coming from a relational world, for example, you might have some sort of built-in functions within your database. Here, you're going to be using DynamoDB streams and Lambda. So to give more guidance to what that is for maybe someone who doesn't fully understand it.
I think that's exciting. I agree with you. It's I think to learn to use DynamoDB well, what I hear you saying is you really need to know how to integrate it well with these other AWS services, these serverless services, so that you can get that true, virtually infinitely scalable solution. And I think what we're doing here, it aligns with that too, right? What we're saying is, hey, for you to really come to DynamoDB, let's say you're coming from a relational background, and for you to come to DynamoDB and design a data model using a completely new paradigm, figure out how to implement triggers or stored procedures using streams and Lambda, and maybe use other services like Event Bridge and so on. Like, that's a lot to learn. Can we, as I said earlier, short circuit that learning, but now not only for DynamoDB, but how to integrate it with these other services to achieve these solutions that you're used to getting in your relational database, although maybe it's hard to scale there.
Yeah, I totally agree. And I mean, this AI stuff and Gen AI in particular is super interesting. We're thinking about this MCP now. It's doing your data modeling. We mentioned the AWS MCP that does maybe your CRUD operations. Like, you can get really inventive with just those two MCPs alone.
Yeah.
You can deploy this data model to production, or not production. Don't do that. To your testing environment, and you can test with it. You can start to write. You have your LLM helping you to write code. You can test it against maybe some of the sample data that the LLM or the MCP has given us here. And you can benchmark, and you can do a world of things with just two MCP servers installed.
Yeah. What I think is interesting about that, one of the other MCP servers in the AWS Labs repo is a data generation server. So like if you think about Faker for Python, where you can create some pretty good data sets to load test, let's say, a data model, imagine a world where you've got this installed. If you scroll up a little bit, you see the types of examples it's already creating for your data in the table that it was showing, right? It's telling us the venue name and so on. You could say to your AI agent, like, hey, I want you to generate some sample data, leveraging the output we have here, and deploy this data model to AWS using the API MCP server, stand up the necessary infrastructure, and try to load test it, like simulate 1,000 writes per second to my venue table, let's say, and collect the metrics out of that through CloudWatch, and see how well that data model performs. I think that's an exciting world, and we're very interested in that, right? Like, trying to create this feedback loop where maybe you could go test out 2 or 3 variations of a data model and see which one is going to be best for you.
Yeah, I couldn't agree more. So, when we think about data modeling for DynamoDB, it is iterative. Maybe the data model is not perfect the first time because you've thought of this additional access pattern that you need to add, or maybe, two entities grouped in the same table isn't going to work for your use case, and so on. So it's iterative, and you can test each iteration. And like we said, with the AWS MCP server, you can do that really easy into your DynamoDB web service. But then you can also think of, you could maybe begin to do that locally in DynamoDB local. You can maybe integrate local stack with it where, you can spin up your Lambda functions and DynamoDB streams and all of those things and just test locally just to make sure that maybe your access patterns, your APIs are configured correctly. So it gets very interesting that the scope that this opens up. And I think this is why I think MCP is probably the best kind of tool for the best maybe wrapper for this tool is that, you're doing all of this in your IDE. If this was a web-based, browser-based thing, then you're going to have to start copying and pasting between there and your IDE. And this just really simplifies your kind of workflow.
Yeah, and I think we've talked a little bit here about like this. We're talking a lot about this early design phase where you're um, getting started on DynamoDB, but I think there's still a world of opportunity for customers that are already using DynamoDB to in the future potentially enhance the way they're using it, or as new features come out for DynamoDB, figure out how to leverage those features. Like we've launched things like zero ETL integration, which you've talked about a little bit. Learning about how to use those things. You could almost have these like living, breathing, getting started guides through guiding these AI agents with the right context, how to get started with new features or optimized for performance and cost. So I think even beyond the getting started experience, there's also a world of opportunities for optimizing existing workloads, I believe.
Yeah, yeah. So we're kind of coming towards the end of this session. We're really interested to know what you think, and take it for a spin. Let us know all of your feedback. You can give feedback directly on the GitHub. You can find me on the Believe in Serverless Discord channel. Just bombard me with feedback. I'm more than happy. We're also open source, and any contribution, whether it's minor or major, is definitely we're really interested in that. If you think of an idea that hey, it'd be great if this MCP server could do X, or I've tried it with my particular data model, it got it wrong. Maybe you can update the context, the prompt that's there, make it better for a particular solution while kind of keeping in mind that it needs to work kind of the majority of solutions. That would be really cool.
Yeah. Yeah, absolutely. Love the love the contributions. And the other thing too is, as we mentioned in the blog, which we've talked about a little bit, you'll see more from us on this. Lee, you already said we think of it like a developer experience tool now. And so, we want to figure out what other tooling can we add to this to provide a better developer experience. And here today, we've talked about using MCP as almost a knowledge base for data modeling, but MCP can use other tools too. Like Lee, you mentioned a little bit ago, like DynamoDB local, right? So you can envision a world where maybe you have a DynamoDB local tool that you spin up and you deploy the data model against that to validate and provide feedback to the AI agent as well. So there could be various tools besides just context, and we're excited to give this to developers to simplify things, but the feedback will really help us. Always go to the Discord. I'm kind of a sleuth on different social media platforms, so if you leave feedback there, very likely I'll find it. But you could also open up issues in the GitHub repo as well.
Yeah, totally. And I mean, the kind of imagination that we have for this tool and that sort of all around developer experience type MCP servers, particular or specifically for DynamoDB, we would really like to know what you want to see. You as DynamoDB users, what do you want this tool to achieve? Maybe apart from data model, or maybe on top of what the current data modeler does. Really interested in your feedback.
Yeah. Lee, do you want to, before we maybe drop off, I guess we have a few minutes. Do you want to say anything about, I know you published a blog as well related to verification or evaluation of data models. Do you want to maybe end with that?
Yeah. So we use DSPY, so a team that works on this. It wasn't me. I get to claim the fame because I'm here on the screen, but they built an evaluation framework that uses DSPy. And really what we do is that we send in, example applications and sample outputs. And then we have scoring rubrics on top where it's saying, hey, make sure that that it's fulfilled all of the requirements that we told it to satisfy. Make sure that the data model doesn't contain hot partitions, for example. Make sure it's scalable. Make sure it's avoiding scan operations because they don't scale. So we have all of these kind of rubrics that we think that are very important when you're designing a data model. And every time we make a change to the prompt that we have for this data modeler, we can very easily see if the score goes up or down. And if it does go either way, we can also see, what's missing. Why did it miss that particular data model? What was it that was missing in the context? And then that allows us to maybe change how the context is ordered, because sometimes the LLM will prioritize maybe what's in bold or what's at the top and things like that. So we can really kind of, it's like seeing through the prompt to figure out the exact point that we need to change and what additional context we need to add there.
I think the other, sorry, I was going to add the other thing that's interesting. There's this ability to quickly test it across many different models as well. And so, in the early days of, I guess, us working on this, a lot of that was manual, which was very tedious.
Yeah, you spent many hours with many different models. That's another tricky part of designing something like this, that we can't just build it that it suits one model. It has to suit the majority. Of course, it's going to suit the popular ones, but maybe more the niche ones that some users might have. It still needs to find its place there as well, and that's where these evaluations can definitely help us.
Yeah, awesome.
Cool. So that's us for us. I don't know if Alan wants to come back on to say goodbye.
Yes. And I apologize if you had answered this question. The moment's lost, but I'm still going to bring it up because we had a comment on YouTube about halfway through the session from Peter. He was just trying to get a clarification. I totally missed this for the MCP server that we were talking about. He said he's been using AWS DynamoDB MCP. That's the one?
That is the one. Yeah.
Yes.
So ask it to help you design a data model.
Okay.
Yeah. So
apparently he's been using it for a while, so he's a good person to get
Thanks,
feedback from.
Great.
And
yeah,
one other clarification from you guys. I know you said you cast a large net for picking up feedback. You'll find it anywhere. If you had a preference for one place, where would you prefer feedback to be given?
yeah, I suppose many different people will be coming from different directions. I think probably majority of people are on LinkedIn. They can ping me directly on LinkedIn. They can get me on the Believe in Serverless Discord channel. And I don't know if maybe underneath the video, maybe I'll leave my email address that, you can pick it up again and just forward me an email address if that's easier for you.
Yeah, or always open up an issue in the GitHub repo as well. Like, tell us what we could do better. That's good too.
Yeah. I don't think I answered your question, Alan, which is the best, and I just named out all of them again. But yeah,
okay.
Whatever your preferred.
We want to make it easy.
Yeah.
Just go anywhere. Okay. So Reddit, Hacker News, anywhere, you'll find it.
That's on my daily list. Yes, we check on those very frequently.
Okay, that's good to know. Okay, I usually ask, where anyone can contact you, but it seems like they can contact you anywhere. This was a wonderful session. Love it. Okay.
Thanks, Alan. Thanks for having us, and thanks for everybody who joined.
Absolutely. Yeah. Thank you, guys. Very cool. And unless you have anything else, we'll see you next time.
Thank you.
Yep. All right.